three levels of teaching and teaching through problem solving. Common Core State Standard, including important part of the expectation. Standard for mathematical practice. Standard for mathematical practice is not a new ideas. This mathematical practice is based on NCTM process standard. NCTM process standard emphasizing the importance of problem solving, reasoning, improve communication, representation, and connections. National Research Council also argued that it's a very important components for teaching and learning mathematics. Traditionally, many mathematics instruction is solely focused on procedural fluency. However, productive disposition, conceptual understanding, strategic competence, adaptive reasoning, all these five are important, and all of them are related to each other. So in order to address these important things, in addition to this, just getting a knowledge and procedures, Common Core State Standard for mathematics including two, which is one is, as I said, Standard for mathematical practice and Standard for mathematical contents. Mathematical contents are described in grade by grade, so they including a clear expectation for each grade level. On the other hand, Standard for mathematical practice is expected from kindergarten to grade 12, all grades. And these are kind of the habit of the mathematics, way of thinking mathematics, way of solving problem. So these are 8 mathematical practice that mathematically proficient students are expected to develop. Make sense of problem and persevere in solving them. Perseverance is one of the big emphasis in Common Core State Standard because many students, if they see a problem, they tend to give up easily. Reason abstractly and quantitatively. So the reasoning is one of the most important part of mathematics. The reasoning is not only justifying what approach you are going to use to solve the problem, but also reasoning to justify their solution. If their solution makes sense, if their solution is reasonable, if your solution is accurate. So those are very important things. Unfortunately, many traditional classrooms, teachers do this reasoning. Teacher demonstrates these reasoning skills, but teachers do not usually asking students to use this reasoning. For example, in a class, the student asks to share their answers. If they say answer, teacher say, yes, you are correct, or no, you are not correct, or that's interesting. However, if teachers say, oh, you are correct, students do not use their reasoning to justify their solution. It is important for teachers to not immediately saying student you are correct or incorrect, but instead we want the student to develop argument, which is connected to the third mathematical practice, construct viable argument and critiquing the reasoning of others. That's also important things that we want students to do during the classroom. The construct viable argument, usually this argument was shared by teachers, but we really want students to come up with this argument. The term argument is different from explanation. We often ask students to how you come up, explain, but argument is more strong word. You want to try to convince other people who may not believe you, who may disagree with you, to convince them by using reasonings. Also critiquing reasoning of others. That means we want the student to have a discussion. Model with mathematics. Teachers often use model with mathematics. However, we want students to use their mathematical model by themselves. In order to do so, they should be able to use appropriate tools strategically. We want students to choose a tool by themselves, rather than teachers say, use number line to show this answer. But rather than that, in order to convince other people, I won't use number line, because number line help us to see something particular. Those are things that we want students to do this. Attend to precision, use appropriate vocabulary, coming up exact answer, or sometimes use appropriate estimation. The attend to precision is also important habit when you use mathematics. Look for and make use of structure. We want the student to look for the structure and then use them, rather than teacher tell them, okay, look at this structure, look at this pattern, you should use it. So all the very important things that we want the student to be able to do by themselves. And then look at the express regularity and represent a repeated reasoning. So like the repeated patterns, the multiplication facts have a certain kind of patterns. And then we want the student to see this. So what does it mean? If you say 144, we want the student to be able to see what is 144. It's not only next to 143 and then before 145. So what is like a significant of this one? And use your reasoning to see what kind of patterns to bring this 144 and something else. So to build new mathematical knowledge through problem solving, that the NCTM are emphasizing since 1980s. To begin discussing what problem solving means, I want you to think about it. What is the definition of problem solving? I give you 30 seconds to think a little bit about what does it mean by problem solving. Some of you might image the everyday world problem or story problem based on the picture book, or more like realistic problems. However, NCTM and then all like mathematics education researchers define problem solving in this way. Problem solving means engaging in a task for which the solution is not known in advance. That means it's not necessarily everyday world story problems. It can be an equation if students do not know how to solve it. So we want students to attack the problem even he or she have never seen before. The reason is the good problem gives students a chance to solidify and extend their knowledge and then stimulate new learnings. So that means solving problem is not the goal. We want the student to learn something new through the problem solving. Therefore, the problem solving is an integral part of all mathematics learning, because we want the student to learn mathematics by solving a problem which he or she has never seen before. So therefore, the mathematics problem solving should be an integral part of mathematics learnings. Unfortunately, many textbooks, including problem solving, as the end of chapter activities, which is not an ideal way of using problem solving. So therefore, like choosing a worthwhile problem and then mathematical tasks is quite important, because a particular problem can be a problem solving or not problem solving because of student prior learning. Student already knew how to solve the similar problem. We do not call problem solving. instead we call exercise. That's the difference between problem solving and an exercise. Definitely, exercise is important to develop fluency or familiar with this procedure. However, problem solving is quite important when you learn something new, like a procedure or a concept or even vocabulary. There are 3 levels of teaching. Level 1, teacher can tell students the important basic idea of mathematics, such as fact, concept, procedure, and practice. We do not think that level 1 is a professional teacher because anybody can be a level 1 teacher if you know enough mathematics. For example, high school student can be a teacher for their younger brother and sister. Parents can be a teacher if they knew enough mathematics for elementary middle school grade. However, the level 2 teachers, those teachers can explain the meaning and then reason of the important basics, contents, and the practice of mathematics in order for students to understand them. It's a subtle difference between level 1 and level 2 teacher. For example, level 1 teacher might say, okay, so when you multiply 23 times 12, what you have to do is write 23 and 12 in this way, and then multiplication sign, and then bar. First, you need to multiply ones and ones, which is 6, and then ones and tens, 4, and then tens and 1, which is 3, and then ones and 2, and then add them all. That's a level 1 teacher teach. However, some students say, well, teacher, when we add 23 and 12, we only did 2 calculations. However, why we have to multiply by 4 times? Level 1 teacher say, oh, don't worry about it, just do it. That's the way you have to do this. But level 2 teacher can explain why these are important. That's a subtle difference between level 1 and level 2 teacher. However, we do not think the level 2 is enough teacher, enough professional. Of course, level 2 teachers need to know a special set of knowledge just for teaching. However, the level 3 is an ideal teaching. The level 3 teacher can provide the student with opportunities to understand these basic mathematical contents and then develop mathematical practices, and then support their learning so that the student become independent learners. So the major difference between level 1, level 2, level 1, level 2 is teaching, teacher teach mathematics. But level 3, it's not necessary for teachers to teach mathematics. However, teacher need to design a lesson so that the student can learn by themselves. These are subtle difference between level 1, level 2, and level 3. Like what I'm doing right now is level 1, level 2 teaching, which can be replaced by online. However, level 3, you have to be in a classroom. Teacher facilitate discussion. Teacher walking around the student to support their learnings. And teachers can pick up the student solutions and facilitate meaningful discussion to help students learn something new. So those are 3 levels of teaching. Definitely you won't be a level 3 teacher, because if you are level 1 or level 2, in the future you do not need in your classroom. Well, online video, online instruction, online lecture can replace you. So therefore this course is really wants you to be able to design level 3 teaching and then teach based on the level 3 teaching. So the one of the most powerful level 3 teaching is called teaching through problem solving, which is your textbook, the bound wall, is talking about. If you give a problem to a student, naturally there are several different solutions coming from student. It's not necessarily the same answer. It's not necessarily the same approach. Sometimes that including wrong answer. Sometimes they include incorrect solutions or misunderstanding. But that's fine because teacher's job is to facilitate meaningful discussion so that the student can learn something new. You do not want to end by just up to here. This is not enough. This is just a show and tell. However, after a student coming up solution and share their solution, this is a time where the teacher helps student learn something new. So that is called teaching through problem solving. And this is a reprint from the principle to action, which is the NCTM, National Council of Teachers of Mathematics, published in 2014. And this is a guidebook for teachers to implement Common Core State Standard. So on the left side, this is called unproductive belief. Right side, productive belief. I encourage you to read through this. We often say our students are not ready for problem solving because they have a weak foundation. But look at this. This is not productive. We need to give students the opportunity to attack a problem. So the problem solving is a way to student learn. Also, the role of the teachers to tell students exactly what is the definition. Those are not good ideas. Role of teachers is to engage students in the problem solving and then facilitate discussion to move student. So students should be able to construct their learnings by themselves. Also on the bottom, an effective teacher makes mathematics easy. Easy for students by guiding step by step is not a good idea. The productive struggle is one of the important terms that many teachers are now discussing. How you could provide productive struggle to your student. This is an example of teaching through problem solving. After students learn multiplication, basic multiplication, single-digit multiplication, teacher may want to show this problem. How many chocolates are there? Obviously, you cannot simply use multiplication. Of course, you may be able to use addition. Also, you may be able to count one by one. So if you show this problem to the student, there are several different approaches. Count one by one, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That might be an approach. However, there are several different approaches. I want you to think about it. How many different solutions you may come up with? So one way might be you're going to spread this into like 2 ways. So this is 3 plus 3 is 6. This is 1, 2, 3, 4, 5, 6. 6 times 3. 6 and 3. And you can add them all. Or some of you might think about it. Oh, that box used to have this amount of chocolate. However, these are missing pieces. We could use subtraction. Or some other ways. For example, so these are way typical, like at least like 3 different ways you can come up with. And we're going to facilitate discussion among students. How you come up. And then, asking student, okay, well, do you think that your idea is correct? Oh, yeah, that works. How do you know? You should be able to explain to your friend about my approach works. For example, this idea, the entire area of this one minus this piece. And many students do not think about it. Subtraction can be used to find this solution. So many of the students may be surprised. However, that is a learning opportunity. After this discussion, you could encourage students to write down my problem of the day, my idea, and then another idea the student come up. And sometimes you may encourage students to come up friends' ideas to write, and then write some reflection. And then teaching through problem solving, note taking is also an important part. So again, we need to think about it, how you nurture students develop mathematical thinking, including problem solving and reasoning. First, everybody, all the students should be able to think mathematically if we teach well. Mathematical thinking can be improved by practice with reflection, give them opportunity to think by themselves, rather than teacher explain it, and then give opportunity to reflect. Mathematical thinking is provoked by contradiction, tension, and surprise. Sharing their ideas, discussing multiple different approaches, definitely give you opportunity to sometimes contradiction, tension, and surprise. And then in order to do so, we need to give students a good question. How do you know? What might be a common idea? What might be a different? Why she used subtraction rather than addition? Those are important questions, and to challenge them and then reflect.